In section 11.5, we're going to talk about parallel lines and triangles. If you look at page 686, we're going to start with postulate 12, the parallel postulate. The parallel postulate states that through a point not on a line, there is one and only one line parallel to the given line. There is exactly one line through P parallel to L. So what it's saying is this. Through a point not on a line, so we have line L, there is only going to be one and only one line parallel to the given line, which is L, that goes through point P. So if you look at the top of the page 687, Theorem 16 is called the triangle angle sum theorem, which is something you've known since elementary school. And that says the sum of the measures of the angles of a triangle is 180 degrees. So the measure of angle A plus the measure of angle B plus the measure of angle C in that triangle ABC would give you 180 degrees. Underneath that, it says the proof of a triangle angle sum theorem requires an auxiliary line. Vocab word. An auxiliary line is a line that you add to a diagram to help you explain relationships and proofs. The red line in the diagram below is an auxiliary line. So you'll notice that line PR is a red auxiliary line. It's not a line that's in the original picture or the original diagram, but it's something you draw to help you. So on problem 1 of the Got It, we're going to use the triangle angle sum theorem. In this diagram, I want you to find the values of x, y, and z. So once again, we're going to use what we know about the triangle angle sum theorem, which is that all three angles of a triangle add up to 180 degrees. So let's start with x. We know x is the third angle of triangle ABD, so we would add 59 plus 43 and get 102 and subtract that from 180, and that will give us 78 degrees. How would you then have to find y? How could you do that? Well, if you find y, you know that x and y are supplementary. So you would know that x and y have to add up to 180 degrees. So 180 minus 78 will give you y, which is 102 degrees. You now know that y is 102. So triangle BDC has a 49 degree angle and a 102 degree angle. So we take 49 plus 102, and we get 151, and we subtract that from 180, and that gives us the value of z, which is 29 degrees. So your three angles would be 78 degrees for x, y is 102, and z is 29. We are now at the top of page 689 in the gray box. An exterior angle of a polygon is an angle formed by a side and an extension of an adjacent side. For each exterior angle of a triangle, the two non-adjacent interior angles are its remote interior angles. In each triangle below, angle 1 is the exterior angle, and angle 2 and 3 are its remote interior angles. So if you look at the three pictures, angle 1 is the exterior angle, which is formed by the extension, and then 2 and 3 are the non-adjacent interior angles, the angles that are not next to angle 1. So angle 2 and 3, we're going to call those the remote interior angles, as they are the two non-adjacent interior angles. So that leads us into Theorem 17, the triangle exterior angle theorem. The measure of each exterior angle of a triangle equals the sum of the measures of its two remote interior angles. So the measure of angle 1 in that picture is equal to the measure of angle 2 plus the measure of angle 3. So if we look at problem 2 says that we're going to be using the triangle exterior angle theorem. Now these two are not written in your book, so if you want to write these down you can, but you do not have to. So the first example shows us that we need to find the measure of angle 1. We're given these two angles inside the triangle as 80 and 18. Now these are what you called the remote interior angles. These are the non-adjacent angles to angle 1. This is the adjacent angle, which we don't know. So 80 plus 18. So all we need to know is this. The measure of angle 1 is the sum of both of those. So the measure of angle 1 equals 80 plus 18. So the measure of angle 1 would be 98 degrees. In the second example, we need to find the measure of angle 2. Well, the measure of angle 2 plus 59 degrees would give us 124 degrees because these two remote interior angles is equal to the exterior angle of the triangle. So 59 plus 2 would give us 124. So we would subtract 124 minus 59, and that would give us the measure of angle 2, which is equal to 65 degrees. In the Got It problem on page 689 under problem 2, it says, two angles of a triangle measure 53. What is the measure of an exterior angle at each vertex of the triangle? So I have a picture, and I'm going to put 53 degrees and 53 degrees. I want to find every exterior angle at each vertex of this triangle. So that means that I'm going to extend this, and extend that. Actually, I'm going to erase this. We're going to extend it this way. And I'm going to label these 1, 2, and 3. So I'm going to find all of those. So the measure of angle 1, the measure of angle 2, and the measure of angle 3. So the first thing I'm going to do is let's start with 1. Remember, you have to add the remote interior angles, which are the non-adjacent angles to the angle you are finding. So the measure of angle 1 would mean that these two are non-adjacent, so I have to have 53 plus an angle. Well, to find the third angle of a triangle, you take 180 minus 53 times 2, which would be 106. So we know that this measure, or this angle that's missing, is 74 degrees. So the measure of angle 1 is 53 plus 74. 53 plus 74 gives me 127. The measure of angle 2 is also 53 plus 74. Those are the non-adjacent interior angles. So that's also 127. And the measure of angle 3 will be 53 plus 53, which is going to be 106 degrees. On page 690, we have problem 3, applying the triangle theorems you have just learned. So here's the got it. It says in problem 3, can you find the measure of angle A without using the triangle exterior angle theorem? Explain. Now, we're going to use the triangle exterior angle theorem first and show you how easy this should be. 80 degrees is the exterior angle. The two non-adjacent angles, which are your remote interior angles, are 30 and x. Well, 80 is the sum of 30 and x, so what would x have to be? X would have to be 50. I mean, that's pretty easy. But can we get that without actually finding or using the triangle exterior angle theorem? And the answer is absolutely. What you'd have to do first is find this angle right here. You should know that 80 and this angle, they are supplementary. Therefore, the angle here will be 100. And then now you have three angles on the interior side of a triangle. So 30 plus the 100 we just found is 130, plus x has to be 180. So you take 180 minus the 130, and that will give you the missing angle, which is 50. So that also works, but it's easier to use the triangle exterior angle theorem. So the vocab that we learned in this section are auxiliary line, exterior angle of a polygon, and remote interior angles.